welcome back. This is part 5 of Project 4, where we are going to take your airplane CAD model and get it ready for testing in the wind tunnel by scaling it down and doing what we need to do to be able to print it and mount it on the sting balance in the subsonic wind tunnel. And then I'll also show you how to just print out a display model of your airplane. Okay, so this is part 5 here. We're going to walk through all of this stuff here. You have two options in this project for what you can print. You can print the full wind tunnel model and join it together so we can actually put it in the wind tunnel, or you have the option of printing a display model. Either way, you still have to turn in your final wind tunnel model CAD to me. You also have to turn in the CAD of your final airplane model with the assembled joints from part 4. You have to turn in a 3MF file ready to slice of whatever printing option you choose, and then most importantly a selfie of your completed print with your aircraft, whichever option you chose to print. Okay, so let's walk through this together with my F104 that I've made throughout this project. And this is the version here that I did last time. It's got my joint in here, and I can see my joint right there. And I want to get this ready for testing in the wind tunnel, and I need to make a lot of changes to this model to do that. So I'm just going to go ahead and save this as a different file name just to make it easier on myself. It is possible to make all the changes in this model and then roll back those changes if you wanted to get to your full scale assembly again. But I'm just going to save another version called wind tunnel model so that I can make all these changes and have both versions easily accessible. So I save this as wind tunnel model, and now that I'm going to print this, I want to get rid of this joint back here that I made for the rudder. It's got this fillet on it, and that fillet results in a very small contact area with the between the rudder and the vertical tail, and that could be an issue in printing. So I'm just going to get rid of that. And the way I'm going to do that is coming down here to my history and rolling back this timeline marker to before where I made those fillets. You can see the fillet's gone here, and I still have two bodies here, so I want to roll it back before that as well. So I'll roll it back one more. Now I've just got one vertical tail here, one body for the vertical tail. And in fact, I probably don't even need this construction plane anymore that I put back here to split that, so I can roll it back one more. And then I can right click and say delete all features after the history marker, because I don't need any of those anymore. Okay. So I got rid of the rudder, I got rid of the joint because none of that matters for printing the wind tunnel model. I'm going to save it again real quick. And now to get ready for printing the wind tunnel model, the first thing I need to do is combine all these bodies into one body. And so I'm going to select all the bodies. If I select to the right here, I'll only get the ones inside of the selection box, but if I select to the left, I'll get everything that touches the box, and that's what I want. And then I'm going to combine all of these things. I've got one of them is going to be treated as the target body. The other three are going to be treated as the tool bodies. That's fine. And I'm going to join all these. I'll press OK. And now I've just got one body here, and I think it ended up under the fuselage. So this one body is my entire model right now. All right, so the next thing I need to do is scale this down to be the right scale to fit inside the wind tunnel. The subsonic wind tunnel has a 3-foot by 3-foot test section, but we wouldn't ever want to even come close to filling that up because of blockage effects. So we want to keep the blockage effects in the wind tunnel down to a minimum, and we've usually found that an aircraft with about a 12-inch wingspan does pretty well and has pretty minimal blockage effects in the wind tunnel. My F104 here is a really low aspect ratio aircraft, so if I made the wingspan 12 inches in the wind tunnel, the fuselage would be enormous. And that may produce some moments on the balance that are undesirable. So I'm going to go shorter than 12 inches. And you need to use your discretion in your wind tunnel model. If you have a typical medium to high aspect ratio wing, 12 inches is probably a good number to stick with. But if you have a lower aspect ratio aircraft than I do, you might want to go lower as well. So my wingspan right now is still 22 feet, I believe. And I'm going to it's coming up in millimeters right now. I'm going to select secondary units of feet, and yep, it's coming up as 22 feet. It says right there. So I need to scale that down to 8 inches. So I'm going to select the body here, and I'm going to go modify scale and the point I want to scale about is the nose point, so I can find this thing after I scale it. So I'm going to select the nose there. And my scale factor is going to be 8 inches divided by 22 feet. If I press OK, here's my resulting wind tunnel model. And now if I measure the wingspan here, I'll change my secondary units to inches. I've got an 8-inch wingspan. Okay. So now this model is the correct scale for putting in the wind tunnel. And the next step here on the sheet is to import the sting cutout into the project. And I've already got it here. If I open up my data panel here, I've already got the subsonic wind tunnel sting cutout in here. This isn't the exact size of the sting balance in the wind tunnel. It's a little bit bigger so that it can fit, so that it can cut the hole size needed to fit the sting balance inside of with the necessary tolerances and clearances and stuff. Okay. So I need to insert this into my design. I'm going to right click on it and say insert into current design. And I'll get rid of the data panel. And it comes in the wrong orientation, but it's pretty easy to flip around. We're going to turn it around so it's can be positioned behind the aircraft. And I can just roughly position it right now. Okay. Okay, so now we need to position this correctly to be able to mount the aircraft onto this sting balance. And the first thing I want to do is make sure that it's lined up centered on the aircraft. And we wouldn't want it to be one side off to one side or the other on the aircraft. So I'm going to choose point to position here. And I need to select a point. And I'm going to select the origin point, and this is the Y direction. I'm going to move it to 0 in the Y direction. So now I know that it's centered with the center of the aircraft because my aircraft is centered on Y equals 0 and the sting balance is now as well. Okay. So I can press OK on that, and now I can come back in, and now we need to decide where to put it up and down and where to put it along the X direction of the aircraft as well. Okay, so the rule of thumb of where to put this along the X direction of the aircraft is we want the aircraft neutral point to be on the center of the balance. The balance is this front portion of the sting balance assembly here. We want the aircraft neutral point to be centered on the center of the balance so that the moments are distributing roughly an even amount of force between the front and the rear of the balance. Okay, so we moved the sting balance so it was centered in the Y direction, and now the trick to get it centered on the neutral point is to put the set screw 1.9 inches ahead of the aircraft neutral point. Okay, and now we need to know where is the aircraft neutral point, and of course the aircraft neutral point is going to be dominated by the aerodynamic center of the wing, and it's probably going to be a little bit after that on an aircraft like this because there is an aerodynamic effect of the tail as well on the overall aerodynamic center of the aircraft. But we're going to use the quarter chord of the wing as the aerodynamic center of the wing and the neutral point of the aircraft to get us close in the vicinity of putting the center of the balance at that point to balance out the moments on the balance. And to retrieve that number, all I have to do is go up here to modify change parameters, and the root chord of the wing was 13 feet. But then I applied a scale factor that was 8 inches divided by 22 feet. Okay, so if I just break open a calculator here, 8 inches is 2/3 of a wing, so of a foot. So if I do 2/3 divided by 22 feet, that's the scale factor that I applied to the original root chord length, which was 13 feet. My new chord length is 0.4 of a foot. In other words, 4.72 inches, but if I divide that by 4, then my quarter chord is about 1.2 inches. Okay, so I'm going to add a sketch plane to make this easy on myself. I'm going to turn on the origin of my model here. Okay, my aircraft's nose is no longer on the origin, so I'm going to fix that really quick by selecting the body, moving it, and I'm going to say point to point. I'm going to move the nose of the aircraft onto the origin like that. So now I've got my aircraft nose back on the origin. I'm going to add a sketch to help myself with this. I'll capture position there. Okay, and now I'm going to again, I need to locate the point that's 1.9 inches ahead of the quarter chord point. Okay, I'm going to add a line here to help myself out locating the leading edge of the wing, which is now buried inside the fuselage. So right now it's kind of hard to, I want to draw a line parallel to the wing, but it's a little hard because of the snap to grid feature that's turned on. So I'm just going to turn off snap to grid really quick, and now I can draw a line here that's parallel to the leading edge of that wing, right along the leading edge. Now I can do the same thing here. And where these two lines cross, I know that's my leading edge of my wing. Okay, so now I need to draw a line that's, I'm going to turn snap to grid back on. Okay, and I'll turn this off just to make it a little bit easier on myself. Okay, so now I want to dimension this line with the distance ahead of the leading edge of the wing, which is different than the quarter chord of the wing. So this is 1.9 inches minus 1.18 inches. Okay, so that point right here now is the point where I want the set screw of the balance to be. So I'll press finish sketch with that, and I've still got my aircraft turned off, but that's fine. I'm going to put the origin of the sting balance, which is lined up with the center of that set screw. I'm going to put that at the point that I just made by saying point to point. I'll select the origin point, and I'm having trouble selecting the origin point because it wants to select the face instead, and it's kind of jumping around on me here. So what I can do is hover over the thing I want to select, and I can hold down the mouse button, and it gives me a bunch of options of things there that I can select. So then I can see the origin. Select the origin as the first point, and now select that as the second point. And now I know that the center of that set screw is at that point, which is 1.9 inches ahead of the aerodynamic center of the wing, which is close enough to the aerodynamic center of the whole aircraft in this case. So now I'll turn on the body of the aircraft again. I'll turn off that sketch that I don't need anymore. And now the last thing I need to do is position this sting balance vertically on the aircraft so it's somewhat centered on the fuselage. And I'll select the free move tool, and this is going to cause a cutout in the bottom of the fuselage of the aircraft here. It's nice if you can keep that cutout combined inside the aft face of the fuselage so that, the only thing that the sting balance is affecting is basically the base pressure on the back of the aircraft, which in real life there would be an engine there anyway. So I'm going to move mine up a little bit so it's not cutting out too much of the bottom of the aircraft as well. Okay, and now we want to check the set screw cutout. This cylinder coming down here is just going to cut a hole for us to be able to get in and set the set screw to be able to attach the aircraft to the front of the balance, and it looks fine. This is just an expansion on the set screw hole to make it easier to get in there when it's a really deep hole, and we don't need that right now anyway. Okay, sometimes we could even attach the aircraft to the balance from the bottom, so we can put the primary set screw on the bottom, but it doesn't matter in this case because the aircraft's not big enough to need this expansion part up here anyway. So I'm just going to press OK on that. All right, and that is the position of my sting balance component that will allow me to mount this aircraft in the wind tunnel in the best way possible. And now I can select wireframe with hidden edges, and we can kind of see the sting balance inside of the model there as well. And we're ready to cut it out. So I can click the combine button. I'm going to capture position so we keep everything in the right place. Click on the aircraft. The tool body is going to be the entire sting balance component. So I'm going to select this part of it, and then I'm going to control select that part as well. That should be everything I need. Now the operation here I want to do is a cut operation, and that's the hole that it's going to cut out in the back and through the top and the bottom. So I press OK. Now I can turn off the visibility of the sting balance assembly. There's my set screw hole at the top going all the way through. There's my hole through the back of the fuselage. Everything looks clean in there. And I think we're ready to print this model out and be able to mount it into the wind tunnel. Right now, this aircraft is, I'm just going to select this here. And so right now our aircraft is 19 inches long. We couldn't print that out on a Prusa printer. The maximum height of the Prusa printer is advertised as 210 millimeters. It's a little bit lower than that in reality. So we need to split this up and glue it back together after we print it out. So we need to come up with a strategy in here on how we want to print this to minimize supports, to make it easy to glue back together, and to make sure that we are able to test it easily. Okay, so I'm going to use construction planes as a splitting tool, so we can move this construction plane back and forth here to figure out where we want to split it. And right now my total aircraft is almost 480 millimeters, so if I split this in half, that'd be 240 millimeters, and if I printed that standing up on the Prusa printer, it would be too high. So I'm going to need to print this in 3 pieces. That's the first thing I need to figure out. Now I need to figure out what those 3 pieces are going to be. And I think this tail would print off pretty nicely by itself. I wouldn't need to have supports underneath this curve, just underneath the horizontal part of the T-tail. So I'm going to move a construction plane back here to right in front of the tail, right there. And if I split it there, I could print the tail by itself, so that would be good. It's giving me a warning here that my construction plane is not visible, so I'm going to turn on the visibility of that. Okay. Right, so there's my first cut plane. And now I need to see how much aircraft I have left to print, so I can measure that again. That's 380 millimeters. If I print that in half, or if I cut that in half and print it, it'll be 190 millimeters each, which will be underneath the maximum height of the printer of 210 millimeters in reality. Like 208 millimeters is a good maximum to stick with when you're trying to print things out vertically on the Prusa printer. So I've got some latitude here on where I select this next point, and if I go in front of here, when this part of the fuselage is printing out, it's going to have to be supported underneath the inlets. That's not a big deal. You know, I could try to go behind the inlets and then print out the front half, but that's 231 millimeters, and that's not going to fit on the printer. So I am going to have to support the inlets, and I'll cut this in front of the inlets there at 200 millimeters. Yeah, that's fine. Okay. So then I'll press OK, and I've got my 2 cutting planes now. So I'll use the split body command. I'll select the body to split. I'll select the splitting tools. There's the first split that's going to take place. And then I'll do it again. I'll select this back body. I'll select the splitting tool. And there's the back cut that will take place. And that all looks fine. Okay, so now I can print out these bodies one at a time. There's the hole coming through the rear body. Okay, but now the trick is going to be gluing these things back together to make a complete wind tunnel model. And if I just have a smooth, flat surface like that come off the printer and I try to glue the rest of the fuselage to it, it's going to be sliding around. It's going to be really hard to clamp in place. So what I want to do is create some alignment holes that make it easy for this thing to go back together. So I'm going to create a sketch there. I'm going to turn off the body, and I'm just going to create a couple circles on here. 10 millimeters is a good circle to go with, and I'm going to create 2 of them. If I just created one of these, I could line it up on one, but then the 2 bodies would still be rotating relative to each other, so 2 of these will fix them in place. So there's, I can't see that sketch, so I'm going to turn that on. So there's my 2 alignment holes on the front half. Now I'm going to create a sketch on this back half here. I'm going to turn off the second body and turn off that first sketch. Okay, so I need to create a 10 millimeter hole here, and I need to see if I have space for a 10 millimeter hole up here. Not really. It's going to be going past the inner and the outer surfaces, so I'm going to put one of these holes here and one of them here in this case. And I've still got my 2 alignment holes then, and they're not sticking outside the aircraft. So I'm going to turn on the other sketch. Okay, so now I need to cut the alignment holes using these circles. So I'm going to use the extrude command. I'm going to select the circles, and this is where a 2-sided extrusion really comes in handy, because I'm going to take it one way 5 millimeters, and I'm going to take it the other way 5 millimeters. I'm going to do a cut, and that'll cut a nice little alignment hole in there. And then the same thing with The same thing with these alignment holes back here. I'm going to do a two-sided one, and 5 millimeters and 5 millimeters. Okay, and so now I've got those alignment holes made, and now we'll need some pins to put in there, but those are actually easier to make in PrusaSlicer. We'll just add a cylinder that's a little bit less than 10 millimeters to our print. 9.8 millimeter cylinder will fit inside of this 10 millimeter alignment hole pretty nicely. Okay, so now I've got these three parts that are ready to print, and I want to export them. And I can actually export them all at once by coming up here to the top of the model tree and saving Save as Mesh. Sometimes when you're saving aircraft meshes with medium refinement, you can run into some issues with the mesh and the smoothness of the aircraft and stuff. So I'm going to choose high refinement here, press OK, and I'm going to save this file to my hard drive. Okay, so I've got PrusaSlicer over here, and I'm going to drag and drop. And it's asking me, should I consider this as a single object having multiple parts? And I'm going to say no, because I want each part to come in separately, because I want to manipulate them separately. Okay, so I've got the whole aircraft here, but I've got the three bodies here, and now I can position these three bodies and get them ready for printing. So first thing I want to do is to put these flat on the bottom of the platter, so I'm going to say to print on this face right here. And that one looks good. And now for this one, I'll print it on this face and try to put that in position. Now this isn't going to print because you can tell because it's a different color, and this dark blue on the wingtip here is actually sticking outside the print volume. So I need to drag it back inside the print volume without going out the other side of the print volume. So I'll just kind of center that up in the print volume. And now for the tail, I'll position that. Okay, so that's a pretty good arrangement here. I can see my alignment holes here, and you know, I don't need any support underneath these holes. The printer can bridge across the top of those holes just fine. I don't need any support underneath the wing. If we look at the wing here, the leading edge sweep of the wing, that should be able to print fine without supports. This curvature of the front of the vertical tail should be able to print absolutely fine without supports. I don't need any supports here. Where I do need supports probably is on the horizontal tail out here. I'll need some supports there, and I'll obviously need some supports on the inletted aircraft here. So I'm going to say support on build plate only, and I'm going to check my setting here for support material and make sure this overhang threshold is dialed back to like 20 degrees to try to avoid unnecessary supports. And now I want to check the rest of my settings. 0.2 millimeters is perfectly fine for wind tunnel models, especially for trying to reduce the print time. 20% infill is a little much for a wind tunnel model. You could probably get by with 10 or 15% infill just fine. I'm going to do 15%. So I'm going to slice this and take a look at what we got. Okay, and this is exactly what I had in mind. The only supports are underneath the inlet and the T-tail. Okay, that T-tail needs to be supported, and the inlets needs to be supported. I don't need supports, you know, for example, inside of that set screw hole. It can bridge across the top of that just fine. I don't need supports anywhere else on this aircraft. Okay, this is looking really good. I think this is going to print successfully. I think I have enough contact area here with the bed. Sometimes with these tall prints, if there's not enough contact area with the bed, they can end up falling over. As the higher they get, the printer is imparting some small forces onto the top of it, which is causing a moment, which can cause it to fall over. But I think I've got enough contact area here. I just need to make sure I've got a really good first layer and check on this print throughout the print. And it's going to be almost a 19-hour print job right now, so it's definitely going to be an overnight job. But I'd want to check on it as much as I could anyway. The only thing I'm missing are the pins to put in these alignment holes, and those were 10 millimeter alignment holes in CAD, so a 9.8 millimeter pin will work just fine. So I'm going to add a shape, a cylinder, and I'm going to go back out here to the editor view. There's my cylinder right here, and I'm going to change the size in one of the directions here to 9.8 millimeters. So there's a 9.8 millimeter cylinder that can act as a pin. And what's important here is that it's only a little bit under 9 millimeters high. So if you remember, I cut that alignment hole out 5 millimeters on each side. So we'd want to stay, you know, under 9 millimeters for the total length of the pin. As long as the total length of the pin is more than 6 or 7 millimeters, but less than 9 or 10, then we're in good shape. Okay, so I've got one of these, but I need 4 of them, so I'm going to press Shift plus to make 4 of these things. And there's my 4 alignment pins that I need to put the aircraft back together. So now I'll hit slice again, and this thing is ready to be exported for 3D printing. Okay, and after it's printed, I'm going to have to get some epoxy, use the alignment pins to line up the different parts of the fuselage and epoxy them together. And then once I do that, I can do a fit check with the sting balance and make sure that everything looks good for testing. Okay, so I need to save this as a ready to slice file because that's part of the turn-in. So be sure to go to File, Save Project As, and save it as a ready to slice 3MF file so that I can check your slice when you turn this in. Okay, so back to the handout here. The last thing I'm going to show you is how to print a display model without the wind tunnel mount cut out and stuff, something that you could have on your desk. So I'm back in Fusion 360 here, and I'm back with my wind tunnel model where I've got this cut out, but I'm going to roll back the timeline marker to the version before I cut that out. Okay, so now that cutout disappeared. So now I've just got my aircraft here without the cutout, and now I can right click on the top and go Save as Mesh, and I'll do high refinement again because it's an aircraft. And instead of saying wind tunnel model here, I'm going to say display model. And now we'll bring this in and talk about how to slice this. Okay, so I'm back in PrusaSlicer and I want to slice my display model, so I'm going to hit New Project. I'll remove everything. I'm going to drag and drop my display model 3MF that I just saved out of Fusion onto the platter here. Okay, so there's my display model as it came in, and obviously it's way too big right now, so I want to scale it down to something reasonable. 1 to 44th scale is pretty good, so I could divide the 22-foot wingspan by 144 and make that my new width, but I'm just going to wing it here. So I'm going to look at my wingspan here. My wingspan is in the Y direction, so in the Y direction right now my model is 200 millimeters wide, so I'm going to do it 100 millimeters wide in the Y direction. So it shrunk it down. That's still looking pretty big for a 3D print, so I'll do 80 millimeters in the Y direction, and yeah, that's going to be pretty big still as well. So 70. Okay, this is something that's more manageable in size and suitable for a display model. All right, if I hit slice right now, this is going to be a horrible way to print my aircraft because it's going to need a massive amount of support underneath of the wing and the tail, and when I take those supports off, I'm going to have a really rough surface underneath my aircraft. So I want to find a better way to print these aircraft, and what we've found works well is to angle them up so they can print as much as possible unsupported. So I'm going to rotate it up right about there, and I'll rotate it a little bit more. Okay, so most of the fuselage now can print unsupported, and most of the wing can print unsupported. Most importantly, the leading edge of the wing will be unsupported, so I'll have a nice clean leading edge, including the leading edges of the tail. So the only thing I need to support in this arrangement is basically the trailing edge of the wing and underneath the fuselage, the back of the fuselage, and underneath the horizontal tail. So I'm going to make sure that my support material overhang threshold is set to 20 degrees. I might even bump it down to 15 degrees because I know these ones can work out pretty well. So I've got that set, so now I'm going to hit slice now. Okay, and there is the sliced view of my aircraft, and I only needed a little bit of support underneath of the back of the fuselage and the tail and the trailing edge of the wing. But I really want to take a close look at this and figure out what's going to happen before it actually happens. Okay, and I'm looking at where the fuselage is going to start. So if I drag my layers down here, my fuselage is building up as this kind of upside down triangle. Okay, and until that triangle connects to another piece here, and it's not really even going to connect to this support, so until that triangle connects to another part of the fuselage, so right here, the back of the fuselage becomes really sturdy because now this big piece is connected to another piece that has its own support, so it's got 2 points of support. But up until then, this was just resting on this piece, and I can pretty much guarantee you that this little piece here is going to fall over as the printer is trying to print it because it's only resting on this little part right here. So I really want to add some support around this part of the fuselage to make sure it doesn't fall over until and make sure it can get to a place where it can connect to another part of the fuselage and get a couple points of support on the bed. So there's a couple of different ways I could do that. One of them is I could come in here, click on the body, click on the Paint On Support tool, and tell it, using the Paint On Support tool, to support a little bit more underneath the fuselage, and hit slice down again. Okay, and as a result of that, I've got a lot more support around the bottom of the fuselage. If I go through my layers here, I can see as this thing builds up, it's getting encased in this support material, which will still come off pretty easily, but it's definitely preventing it from tipping over. And then it can connect to the rest of the fuselage and keep on building successfully from then. So that is definitely something that I had to do to keep this, to make this print successful. And besides that, I think that this is going to work really well. This is going to be a really nice print. I'm going to try this one. It's going to be about 3.5 hours to print, which is pretty reasonable for an aircraft like this, and it should make a nice smooth display model with nice smooth curves and surfaces on it. Okay, and once again for the final turn-in, I want the Fusion 3D file of your final airplane CAD with the assembled joint, full scale. I want it's going to be a Fusion 360 archive file, F3Z file of your wind tunnel model, split with the alignment pinholes, a 3MF file ready to slice of whichever printing option you chose, and then a selfie of your completed print. And just like Project 3, I put the due date of the selfie a week past the due date of the rest of it to give you time to get your print done. All right, and just one more time, all you have to do to get to those F3D files is go File, Export, and the F3D file is the first one that pops up, so you can save that file to your hard drive. For the wind tunnel model, if you go File, Export, it's going to export it as an archive file because it's got the Sting component in there as well, which is fine. Okay. All right, so that covers it for Project 4. I hope you have fun with this project, and I'll see you in class. The other thing that I want to warn you about is trying to print and slice thin parts. Okay, the nozzles that we have on our printers are 0.4 millimeters wide. So it's physically impossible for the printer to print a feature that's smaller than 0.4 millimeters wide, and the printer will just ignore any features that are smaller than that. For example, trailing edges, where the wing comes to a very thin edge at the back. Sometimes, especially when you scale your model down, those trailing edges can be less than 0.4 millimeters wide, and so the printer can't even print them. So on the left here, you see my unsliced raw geometry of an F104, which shows the wing shape that I actually made in CAD. But when I go to slice it, PrusaSlicer can't slice the back of this wing because it's so thin, so it can't even start printing until the wing gets thick enough to where it's 0.4 millimeters thick. So what happens here is PrusaSlicer puts supports underneath the wing to where the actual geometry comes, but then in reality it doesn't start printing it until it gets thick enough, and I end up with this gap between the supports and the wing. And this part will fail because the wing is unsupported. And beyond that, it won't even look like a real F104 because the wing will be a different shape. And look at the tail here. The tail just became this little triangular tail here with a lot of area missing compared to the actual geometry. So this F104 is going to look a lot different than the CAD file that I made in Fusion, and it's because I ended up with parts that were really, really thin, and PrusaSlicer just can't even print them. So there's 5 possible solutions that I've come up with for this problem. The first and best solution is to make the wing thicker in Fusion 360 a little bit, and I'll show you how to do that in Fusion. The second solution is to make the part bigger in PrusaSlicer, and as the part becomes bigger, the smallest feature also becomes bigger, and there's a chance it may be able to print more of the wing. But sometimes you may not want to make your part that big in PrusaSlicer, so that may not be a good solution. Sometimes, if you draw a sketch at the trailing edge of the wing that's 0.4 millimeters thick and extrude it into the wing, then you're guaranteed to have a 0.4 millimeter minimum thickness on the trailing edge of the wing that will print. So sometimes we have to do this. Another solution is to print the aircraft nose down. If you can support the nose good enough so the aircraft won't come off the bed of the printer while it's printing, this will let the printer print the leading edge first, which means the print will get supported, but it still means the trailing edge will come out to be a different shape. It just means that it won't fail because it was unsupported. Finally, you could try to print your aircraft in more of a horizontal orientation, and this will cause more of that thin trailing edge to be rotated down into the XY plane, where the printer can actually resolve a smaller feature than 0.4 millimeters because we can go down to a 0.2 or 0.1 millimeter layer height in the XY plane. Okay, so these are I've kind of presented them in order of preference. The first and best option is just to make the wing thicker in Fusion 360. So that's what I'll show you right now. Okay, so I've got my F104 here in Fusion 360, and the key to this is going to be to make sure that these wings and tail are not combined with any other bodies. If you combine this all in one, this trick will probably fail, and you need to uncombine it. So go back in your timeline and uncombine these things, and then try to make the wing thicker. And the tool that we're going to use is the press pull tool, and we can just click on a surface or a face of the wing, use the press pull tool, and we can actually just pull it out and make it a little bit thicker. Now this tool is kind of like the fillet tool, where if we just grab that handle and pull it out by a bunch, the operation's probably going to fail. But if we type in small numbers here and only do small changes, we can see the wing get thicker slowly. Now we're losing part of the wing shape here, that's for sure, but I've kind of exaggerated how much thicker we need to make it in this case. In this case, I only had to make it 0.2 millimeters thicker, which was 0.4 on both sides. And this actually still looks pretty airfoil-ish and results in a successful print. So this press pull tool and making your wing a little bit thicker is the first solution that you should try for that thin part problem.